Good afternoon, everybody. I think that was an aha moment right there. You following along? You following along? There you go. He's got it. I'm Clay Morey. I'm the CEO of AIAA, and you know what? Last year was my first DBF, and I loved it. It was so much fun. It was so amazing. The volunteer teams that put this thing on were incredible. It was hot, but it was dry out there in Tucson. I mean, it was like 2% humidity. It was like 100 degrees. We had a few dust devils roll through, but the excitement was incredible. It was incredible. And we rolled out our new AIAA logo at that event. We had hats, we had t-shirts. It was super duper fun. And this year, we're celebrating the 30th anniversary of DBF. And it doesn't look a day over 20. I used that line in the opening thing, but okay. It still looks great. For 3 decades, DBF has challenged students with real-world problems. We do these different sets around the flights and what they're going to carry and the competition. And it's an amazing competition to see students come together to build things, sometimes to break things, rebuild them, fly them again. And it's an incredibly important thing. And I can tell you this from working in industry for over 25 years. When I was at different companies, we looked for students that had been team competitors, that knew how to work in a team format, raise money maybe to get there, to break things, to fly things, to solve problems on the ground. And so it's a critically important thing for any of you students out there to think about being a part of competitions like DBF. You know, it's our largest design competition. It's the largest aviation design competition that I know of in the aerospace industry. We attracted over 1,200 students last year. We had over 100 teams entering, and it was just super fun. Very much international as well. We had teams coming from all over the world, from India, from Bangladesh. A team from Austria won the competition. A team from Australia came in second place. Santa Clara was right up there to the last second until the Austrian team nailed the landing, and it was their first time in the competition. So it was really very exciting. It is the most exciting time right now to be in the aerospace industry, to be a part of what's happening, particularly in the aviation side of the house, what we see on aviation right now with supersonic flight, with eVTOLs, with ultra-short takeoff and landing aircraft. What's even happening on the larger scale commercial airframe business is super exciting. So there's a lot of evolution that's taking place, and these places are great, and we see a tremendous as well turnout from our corporate members now that are a part of this competition. This year, we're going to be in the air capital of the world. Self-proclaimed, not me, but you know, Wichita, Kansas says they're the air capital of the world. I think there's like 600 aviation companies that are there in the greater Wichita area, and they bring it. And so it's going to be an exciting place to have this competition coming up this year. We've got 101 teams that we've invited to participate from April 16th through the 19th. We're excited to be there. Hopefully the weather's going to be good. And we're going to be able to see some great flying going on. We've got some new stuff. We've got live streams that are going to be taking place this year, so you can follow the scores online. You can stay up to date. You can see exactly what's happening on the flight line. You know, we've talked to FanDuel and DraftKings. There is no wagering this year. I just want to make sure you know that. But it's going to be a lot of fun to watch this thing online and to have it come on. You know, we've got official 2026 competition for the t-shirt. So if you want to visit the DBF website and for more information, and now you're going to hear more from Taylor and the team during the talk today. So please welcome Taylor and the team up. Yep.
All right, so show of hands, how many of you are at least relatively familiar with Design Build Fly? That's like 98%. We're going to do the faster, funnier version because 45 minutes is not a lot of time, and we have a lot of stories across 3 decades of this competition. So I'm going to do a disclaimer first. If you are a student and you're participating this year, I will not answer your questions about this year's rules. Please submit your questions through the online form for Q&A too. Okay, high-speed history lesson. So these were the founding fathers of Design Build Fly. These were the guys that helped get it off the ground, really got it moving, got the momentum and the inertia going, and they've really built it from the ground up. We have one of them for the panel today, which is really exciting. So it was made as an alternate to SAE Heavy Lift, which is another collegiate aircraft competition. It's still going on today. They wanted to provide an opportunity for hands-on, practical experience that was not just a model aircraft competition. We design new aircraft requirements yearly, so there's always a different design. The planes look very, very different. We have 2 on stage from 2 very different rule sets, very different size planes. And the committee is organized and executed by technical committee volunteers. So we have 4 TCs that were the founding members. We also now have standing committee members as part of the organizing committee. And then, of course, AIAA and the foundation and our sponsors helped to put the event on as well. The first fly-off was in 1997. So doing some math, that's not 30 years from 2026. The competition had to start in 1996 in order to get that fly-off in 97. So the math works, but we have not had 30 fly-offs. Thank you to COVID, thank you to tornado and some other problems, but we're getting there. So now the general format of Design, Build, Fly is you submit a proposal. Then if your proposal gets accepted, you submit a report in February, and then you come out to either Kansas or to Arizona for the fly-off in April. So I want to acknowledge our current OC. We have myself and Matt from the current OC, as well as some other members that are currently in the audience. And there is a name that runs through both of these. So Chris has been the Iron Man of the flight line at this point. Any of you who have participated have probably met Chris Bovai. He is still on the OC, and we are so happy to still have him. I'm sure there'll be a big party for his last competition. All right, so the organizing technical committees: applied aerodynamics, aircraft design, design engineering, flight test, pretty much the 4 major ones that you need to design, build, and fly an airplane. We also have 3 major sponsors. So when we're in Kansas, that is mainly hosted by Textron Aviation and Cessna. The AIAA Foundation provides support for all of our events. And then when we're in Arizona, we have RTX, specifically Raytheon. We do have corporate liaisons on the OC for all of those sites to make sure everything flows smoothly, that we have water, that we have food trucks so that everybody can eat. All right, everybody loves data. Here we go. So we have a lovely line plot of entries over the years. Proposals accepted, you'll see we just started accepting proposals in the 2015 range, so that's why the orange starts a little bit late. The total submitted reports, the total number of teams that came to fly off, the total teams that survived tech inspection, and the total number of teams that survived tech and then also got flight scores. You will see a little redacted box there. That's the dark ages, the COVID time. We don't talk about that. All right, some more data. So this is the number of teams participating in the competition in the blue line, and then the total number of flights over the course of that competition. You'll see a really lovely tornado there in 2012 that prevented flights, as well as COVID and an extremely windy year following our return after COVID. For those of you that like to raise a fuss about the number of teams versus the number of flights total, if you do the math here, it generally works out to between 2.5 and 3 flights per team every year since we started. Hasn't gotten much worse. I see you. All right, so this is probably an incomplete list of all of the payloads that we have had students put into the aircraft over the years. We used to have just straight steel plates, water bottles, there's been water tanks, bats, pretty much any form of sport ball, from Nerf footballs to golf balls to hockey pucks, which was carried in this plane. We've done soccer balls, bouncy balls, those were a nightmare when they crashed. Some hockey pucks, and we've carried gliders, straight aluminum, all sorts of syringes and rockets, and you name it, we've told people to put it in their planes or attach them to the outside. I'm sure I've missed a couple, but there's some fun ones in there. So 1997, there weren't a whole lot of teams. It was only US-based. I think there were 12 teams total. I think 9 made it to competition. I am not collecting the data for all 30 years. That is way too much. So we're going to jump to 2002. We get an international presence. You see a very large increase in the number of teams. We go to 2007, even more international presence. 2012, now, if you don't see your specific school, it's because there's like 12 different schools that are one pin now. We got a lot of teams once we hit the 2010s. 2017, continuing, we started getting some friends from Australia. We started getting friends from South America, from Alaska, and we've continued that through 2025. This is all of the teams that participated last year. So we really have grown an international presence over the years. We've had lots of winners and very competitive teams from overseas. And it's really exciting for the students to get to interact with international students and make those lifelong friendships that they forge at the competition and at the fly-off. So next, I want to bring up all three of our panelists. So we have 4 generations of DBF. So if Dave, Matt, and Camden can all come up and join me on stage, we'll do some quick introductions and then story time. And while they come up, I will note, if you'd like to submit a question, I will be polling those once we get through some of our stories. Go and do that through the AIAA Events app. I can see those questions up here. But first, let's do your name, your company, and what your involvement with AIAA has been. So we got Dave first.
Yeah, Dave Levy. I'm a senior principal engineer at Sierra Nevada Corporation right now. I was with Textron Aviation, then Cessna Aircraft from 1993 to 2016, and my involvement with AIAA?
With DBF.
With DBF, and I was on the organizing committee for the first 20 years.
Hi, I'm Matt Angiulo. I am on the organizing committee. I've been on there since 2007 when Raytheon became a sponsor of the competition. I have multiple roles when every year, I organize the judging of the proposals and the reports. We do have a few of our report judges here in the audience today. And then when the competition is in Tucson, I'm responsible for the facilities and getting everything set up to host the competition.
So I'll jump in. I'm the next one. So there's my face. My name's Taylor Fazzini. I'm currently on the organizing committee. I helped start the Design Build Fly team at Embry-Riddle in the 2014 to 2018 range, and then joined the OC in, I think, 2022. So I've been both a participant and an OC member, just like Matt. And then last but not least.
My name is Camden Doucette. I'm a current student at Embry-Riddle, and I'm currently on the DBF team there. I have been since 2022. And I was fortunate enough to do several things there. One of them was team lead. I got to direct the construction of Viper here on the stage with me. I've been a manufacturing lead. I've done composites work. I've done everything that there is to do with a DBF team. And for this year, I'm really excited about it. I'm on our design team doing our propulsion design. And I'm also a co-op with Gulfstream Aerospace, and I'll be working there full-time in the summer.
All right, so I want to give all 4 of us an opportunity to tell a story. You have 5 minutes. I will call you out, Dave. Go for it.
Let's see. I thought you had the picture of the.
Turn around too if you want to.
Oh, okay, thank you. Yeah.
What you got?
So I got involved with DBF about 2 weeks before the first fly-off. I need to give a shout out to the actual founding fathers, even though I've been called one. Those would be Greg Page, Mike Selig, Chris Beauvais, and Stan Powell. Those guys were really the genesis of this competition. I got in not quite late to the party. I remember the very first fly-off where we got in a car. Got in late. It was 1997. Back when GPS and maps was not so good, and we started driving and driving and driving. And pretty soon the GPS didn't have a road. We were just kind of off in the wilderness, and I was beginning, it was about 9 or 9:30, and I was beginning to wonder if we were going to have a bed to sleep in. And finally got to this private island and a big house, and all of a sudden I realized this was the best boondoggle I had ever been on. It was fantastic. You can see the variety of airplanes. We did have a fair number of scoring flights in that competition. The second fly-off was not quite so lucky. That was at an airport in southwest Wichita called Dead Cow International. I think it has an official name. I can't remember what that is. The weather was miserable. It was 45 to 50 degrees and blowing and rainy, and we had 4 scoring flights, just enough to award the top 3. The figure on the top right is the tornado year, which was 2012. That was quite the experience. The tornado did not happen when we were actually flying. Greg Page used to joke that we would never cancel flying unless there was actually a tornado on the field. He began to eat those words after that year. We did suspend flying about 2:30 that afternoon. Because of the extremely high winds. Even for Wichita, they were very high. They were about 35 knots something like that. So we finally suspended about 2:30, and then the storm front rolled in that evening. I was actually responsible for the fly-off operation that year, and I was up until 2 a.m. that night after the tornado had run through, trying to get a hold of people at Cessna, trying to figure out what the heck was going on, and finally at daybreak went out there, and unfortunately there were power lines down on Pawnee Avenue, which was where the entrance to the field was, and we could not access the field. And so we did find a way to come around through Cessna property and then up to where the hangar was. And so we escorted teams through Cessna to come and recover their stuff. The hangar itself was okay. The door was kind of off its hinges, but there was a hot dog stand that got flipped, and unfortunately it was totaled. So let me close real quick. I think I've got a minute or so. Two things really impressed me about this competition that was one of the reasons I stayed so long was one, just the teams and how they cooperated. There was teams that were more experienced that would take newbies under their wing and help them out. They would give them parts. They would help them repair their airplanes. So the sportsmanship was just unbelievable. And then the other thing that impressed me was how students that had been through the competition afterwards started showing up at the competition, at the fly-offs, and volunteering. Rip Rippey is a name that everybody should know. I'm trying to remember if he's not on there. That's too bad. If anybody's been around for a while, they know Rip. And then several other people that have become on the organizing committee. And so if the students enjoyed it that much, maybe looking back on it, they've forgotten all the bad stuff. But just the fact that they kept coming back and volunteering and helping things. Taylor's one of them. I don't know, Camden, I guess it's on you moving forward. Just the new generations kept coming back and helping out. And it's like, that's really when I knew that we had something going. One final shout out, two more of the organizers are here. Ed Feltrip and Kelly Laughlin are in the seats there. Keep it going, guys. You're doing a great job.
All right, next, the pictures that Matt's getting, I call from his cool boy era, so we'll get a story from Matt.
Yeah, two of my favorites. I was the first member on the organizing committee that competed into the competition. These years are, let's see, the one on the far side there, that's 2000, and the biplane is 2001. I remember in 2000 we had to carry 1 liter water bottles, and you could carry, I think, up to 8. To this day, I know that water is 2.2 pounds per liter because of that. And then in 2001, we had 2 missions. That was when we started adding missions, or when the committee started adding missions. That plane had to carry steel. It was as much as you could carry, and you got points for each pound or ounce, and tennis balls. You could carry, I think, up to 100 tennis balls, and we had to swap them out when you went and flew a mission. So that plane over there had a 5-pound NiCad battery that did electrocute me once. It could start a car, and it carried 40 pounds of steel, which was the most, I think, that year. So a couple of fun stories about, I guess, the early years. Though I was the first on the OC to have competed in the competition, Jason Merritt, who's also in the audience here, he competed a year before me, I think in '99, and then we competed together in 2000, I believe. So Jason joined the OC for a period of time there before he went back to academia. Now we have many members of the organizing committee that are previous competitors. So Taylor, obviously, it was me first, then Jason, and then we were followed by Rob Redditz and Chase Ashton. So now there's 4 or 5 of us that competed, and we're really honored and privileged to be part of the OC and happy to move it forward. The only other thing I'll mention here in my remarks is I also, my particular role is I'm the RTX representative, or the Raytheon representative on the OC, and Raytheon has always been really proud to be a sponsor of this competition. Specifically because, when we say it's a real world experience, it 100% is. The things that the way we organize the competition is very similar to the things that you will do when you're out in industry. We get requirements for new products at very inconvenient times where we have to roll proposals and write proposals. Many times we do not know the criteria by which they will be assessed and graded. There's usually a down selection where we then need to quickly go and design a vehicle with many challenges, competing requirements, over-constrained problem. We like to bring a little flavor of things that we face, like control surfaces that have to fold and fit in tubes, or things that get dropped out in the field. So they're honestly real world problems. That's why those of us who've competed are so passionate about it. I enjoy every year seeing your ingenuity, the passion we see from every team, the cooperation, and it's just a great thing to be part of. So I'm privileged to still be on the OC and go every year.
All right, so I brought a prop here. I think every design build fly team now is really, really good at naming their planes. So this is Plane Gretzky. He carried hockey pucks, named after the GOAT. He has a really cool boom tail. Camden grabbed this from the lab. This plane is almost a decade old. This was my plane in 2017. And one of the stories I want to tell is about the really janky ways that teams figure out how to make it work. So top left picture, we built a vacuum form table in my apartment to make the cavity here to hold hockey pucks. So we warmed up some plastic in my oven that I continued to use to cook food that I ate out of until I graduated, so that probably wasn't great for me. Hooked up a table that we drilled a bunch of holes in with a Dremel. We threw that hot plastic over some foam that we hand carved and sucked that pod down. It was almost impossible to cut because that plastic hardened really quickly. So both my husband and I suffered many cuts and scars thanks to Plane Gretzky. But that same year at competition in 2017, so both of these pictures is the story that I want to focus on of kind of the spirit of the competition. So the guy in the green polo in the upper right photo, his name's Ribhu Bhatia. He was from a team in India. He was the only team member that was able to get a visa to come to the US for competition. That year, we hand-launched the planes like a javelin. His plane was about 15 pounds. So one of the guys from our team, the one on the far, far left there with the really big biceps, threw Boo's plane for him. It was a little bit of a throw-together monster, basically built out of hardwood. And it crashed the first time. It caught on fire. It was a whole situation. And so Embry-Riddle adopted him as kind of one of our own. He ended up staying with us in the hotel. He went to all of our meals afterwards. And I think about 15 different teams provided parts to rebuild Boo's plane. So that bottom picture is all of the teams that contributed time or energy or resources to build his plane again. We all signed them, and he got to fly his plane again at the very end of the fly-off, not as part of the competition, but kind of as the spirit of all of us coming together, donating their parts, making sure that someone's experience who came here from overseas was a really good one. We kept in touch with Ribhu. Some of us keep in touch more often than others. He did a master's degree in Italy. He's doing a PhD in chemistry in Italy still. And that was kind of a lifelong lesson for all of us in the spirit of competition, in working together, in understanding that once your plane makes it through tech inspection, no one else is stealing your design. They're not going to make their plane instantly better because they see what you brought to competition. So be friendly and learn from each other. And I think that was the biggest thing that all of us took away from that competition. I know a lot of the AIAA staff that was here still talks about that year and how neat it was to see everybody come together like that. So then lastly, we'll pop over to Camden.
Yeah, so I'm going to provide a little bit of a different perspective just because I'm a current student. I wanted to talk about Wrench, the airplane Wrench. It won the 2024 competition on the 10-year anniversary of the Embry-Riddle team, which was awesome, a high that I will probably be riding for the rest of my life. But for this plane, I was our manufacturing lead, so I got to deal with the manufacturing, the timeline, procurement, all of that kind of things for an airplane like this. And because it's pertinent to the story, I'm sure most of y'all are familiar with the rule set this year, but this is a Wichita year, civilian kind of rule set. The whole thing was urban air mobility, so we had to take off within 20 feet, which was a feat for a plane that was almost 30 pounds fully loaded. We had to do a lot of special things to get that to happen, which I'll talk about in a second. But The other things we had to do with this, the wings had to fold within a 2.5-foot wide parking space. We had to carry these little wooden dolls. Our plane was able to carry 117 of them, and that was a pretty impressive ground mission effort that year. But it was a ton of fun. It's amazing, and I'm up here to highlight kind of the student experience, and it's been one of the most amazing things ever. I can't wait to be in the position of the OCs that are up here and talk about my years in DBF fondly, but I'm still experiencing them, thankfully. So. But like I mentioned, Wrench is kind of an interesting plane. We had to take off within 20 feet, and we weighed almost 30 pounds fully loaded. So that picture on the right, that's the plane in flight. We actually developed Fowler flaps for this aircraft to get just the most efficient possible, best CLmax for our takeoff run. So that was something new for us. That was a huge development process, and they worked out really well for us. They looked awesome. But another thing that we needed was a ton of thrust and a ton of torque to get that airplane off the ground in 20 feet. So in order to do that, we had to do something special. This year, also, I meant to mention, we had to have 2 pilots in the front of the aircraft that are like looking out of the plane. They had to have a field of view, which basically meant for our nose box, the top part of the nose box is basically gone. It's a nose C-section, if you will. So looking back, I was manufacturing lead. We just spent a long, like 4 years. The first video's not working.
If AV could help play the first video.
Unfortunate. Well, I'll tell you what happens in that first video. It had been like 4 weeks of us manufacturing. Everything was going great. And in the first video on the left, we spun the motor up, and it shot out of the airplane. Took the ESC with it, took the firewall with it, and we just stood there just dumbfounded. It was like literally the worst feeling ever. And looking back on it, it was hilarious. But at the time, it was a huge problem because we needed this big motor. We needed it to be able to take off. So all of a sudden, we've got another challenge on our hands. And me and my team were like, man, we're not going to be sleeping for the next 2 weeks, are we? So I do want to mention the dates on this one. This one on the left, which is, again, just imagine it, motor just going out of the plane. This happened on November 18th. And one of the things that I really love about this competition is these kind of challenges that happen. So the video in the middle, that's on November 21st of 2023. So 3 days later, we had a test section, which was the top like quarter of the airplane. And basically, that allows us to rapidly prototype to try and fix our really flimsy nose box. And so in that first video on the left, the entire firewall is sheared out of the airplane. We've got 4 longerons running into the firewall. And the first video, it just takes it all with it. In the second one, if you notice, it actually doesn't take the entire firewall with it right before it falls over. It only takes a little bit of it. So in the first video, we realized, we stepped back, we have a torsional stiffness problem, right? We're all nerds and engineers, so I figured that would be interesting. But we stiffened it torsionally, the middle section, that video. Now all of a sudden, we've got an axial problem. But the firewall doesn't shear out that time, so we know that we're good. We're torsionally stiff. We're good there. So even though everybody groaned and sighed and made terrible noises after that second run-up, because we were really hopeful, we learned something so we can move forward. And if you notice in that third video, we switched our firewall out from a wooden one to a carbon fiber firewall, and that fixed our problem. We spun up that motor, all the torque that we needed to take off from that 20 feet, and it worked beautiful. Nothing happens. It's a very boring video, but everybody in the background of that video was just cheering. So that was a really awesome experience for me. Well, it wasn't while I was manufacturing lead. I was like, man, this is the worst. But looking back on it, DBF is such a cool thing because you can kind of, as a student, really apply what you're learning in the classroom to a hands-on situation like this, where we have a critical failure in our structure, and we need to figure it out as soon as possible, or else we're not going to get our testing in, and we're not going to be able to hit our performance numbers and our propulsion numbers. So just seeing everybody get together, rapidly problem solve, prototype, figure it out, get it working, and then get the plane back up into the air again and go on to win the competition was just an incredible experience. I'm very fortunate to have been able to be up on this panel with everyone. Thank you, Taylor, for inviting me, and just represent the students of DBF, the current students of DBF. And I look forward to competition this year, another Wichita year. So.
All right, so you got a little snippet of stories from each of us. The Q&A is up. I will be asking questions from that, so feel free to submit your questions if we run out. I'm sure we all have more stories. And then if we can just switch to the photo slideshow again in the background on loop, we'll work through it. So the first one, I think they'll go more towards Dave and Matt. When you hear a student or a new hire was a part of Design Build Fly, what do you ask them?
I'll go first. First of all, I asked them what they did and listen to what they say. Whether if they were a program manager, how did they organize the team? How did they manage the team? What were some of the challenges? Because team dynamics can be a huge issue, both in student competitions like this and once you get into industry. Guess what? Virtually everything you do will be a team experience, a project experience, and it's how you interact and how you all support each other and make whatever it is that you're trying to do work in the end. That's the goal. And so how did you manage that? Or if you were an individual contributor and you had a technical role, talk to me about the technical role. But just let's go back to the beginning. If I see somebody participated in DBF in some sort of meaningful way, that's a plus in my book.
Yeah, so I do a lot of hiring at Raytheon, particularly for my department, and I always look for AAA involvement, and I certainly look for design, build, fly. I always love to see it. I usually ask them what year the competition was, and I also ask what they did on the team. It's always interesting when I think you talk to somebody who competed in DBF because they have a lot of stories and things to share. Everybody, like Camden, lived through the late nights and the things that went wrong and the challenges overcome. And so I usually look for those sorts of things because that really tells you a lot about a person and an engineer, how they approach problems, how they face problems. It's always something that I enjoy talking about. I do recall maybe a year or two ago, I was interviewing a candidate who participated in DBF, and he said he wrote the report. So it was a Zoom interview, and I'm at my computer, and I have every report since 2007 on my computer. And so I pulled up his report and we took a look at it, and we talked about it. So that was a fun moment for him, I'm sure. It's always great to see DBF participation, and I think those. I know from my experience when I interviewed at Raytheon, it's a lot of the stories that I shared or the things I shared were from my DBF experience. And I know the students that participated, it gives them a lot of great material to talk about when they interview in the future as well. So.
Perfect. All right, so this is the top question right now. Probably each have our own answer for this. What is the best lesson learned that you remember from throughout the years? I'll give you a second. I'll do mine. So our first year, we had a really big plane. Her name was Big Bertha. She was not cute. Our second year, we thought, oh, well, everyone at competition built their plane out of carbon fiber. We should do that. That doesn't always work, but depending on everyone's experience levels, when you're all freshmen and sophomores, your plane's probably going to be really heavy because you're putting way too much epoxy on your carbon fiber, on your fiberglass. And so we went, okay, let's use the technology that the winners are using. And we did better than the year before, but we still didn't win. And so I think one of the biggest things there is understand the technology that you're hoping to incorporate. It is not a magic wand that is going to instantly make you win. And you really need to understand whether that is the best thing for your design. You see each year teams build their planes out of balsa, they build them out of carbon fiber. We've seen both teams be equally successful in the same competition year with the same rules. And so it's really understand the expertise of your team, understand the limitations of your equipment and your budget and what you can work with, because not everyone's going to bring the same solution. Some people are going to make gigantic planes and biplanes and giant wings, and other people are going to bring a tiny, tiny glider, and they all accomplish the same mission. So make sure you're creative with it and really thinking about what you guys can be successful at and excel at. Dave? Matt?
My turn. Can I have two?
Sure, as long as they're quick.
First of all, the lesson that I think hopefully the students learn as engineers, things don't work out in real life the way that they look on paper. That's the first lesson. And by making you run a problem all the way through to actual demonstration, you learn a lot of things that you wouldn't expect to learn. Let me flip that to the governing committee. As Taylor pointed out at the beginning, we change the rules every year. We learned about, on the governing committee, we learned about the law of unintended consequences. We would make a rule change and think that we've got it all figured out, but guess what? DBF is this wonderful experiment in crowdsourcing. When you get 60, 70, 80, 100, 150 teams all trying to game the system, figure out how to score. And the best example of that was one year in Tucson, I forget which one it was, when we were using golf balls as the payload. And MIT fielded a team that flew one golf ball, but they drove the weight down to just a minuscule amount. I think the airplane weighed about 1.5 pounds with the golf ball. And so even though the payload and the flight score was not that big, the denominator got really, really small. And lots of people debated whether or not that was in the spirit of the competition, and it's like, well, that's the rules. And so we didn't expect it, but they figured it out.
I'll add a quick one to that. Matt and I experienced this in 2023 when people had to load weight onto the wings of their plane, and that was part of their ground score mission of the overall weight. And I think as an OC, we expected the max weight that people would load on to be like 100, 150 pounds. University of Aachen from Europe came in and loaded 1,000 pounds of cement onto their plane. And we were not ready for them to basically clear out cement blocks from Home Depot in the greater Tucson area that year. And so it really goes to, we think about what we think the loopholes are and what we think the crazy limits of some of these planes are going to be, and y'all outsmart us every single year. And it's a joy to see, and sometimes it's inconvenient for us and we get a lesson in agility, but it's also really interesting to see how they figure that out.
I'll give you a story from my first year competing, which was the 99-2000 year. And we had no idea what we were doing. The competition was still very new then. I think that was the fourth year or so, fifth year. And so there wasn't, we post the best reports and now we post the best proposals, but there wasn't a lot of that to draw from. And we were just making everything up as we went. And we got to the end of the year and we were throwing together a report at the last minute as if we had been working on it all along. And it really just, the light bulb went off of like, oh, we should have done this sooner. We should have we should have come up with a plan and a schedule. We should have thought about testing. We should have thought about manufacturing while we were designing the thing. Just everything clicked, which is why, the difference between you can't tell it in the picture, but the 2000 year and the 2001, we came back a completely different team, much more successful, and it was just going through that whole process that we learned that sometimes the people dynamic is the harder problem to solve, not necessarily the technology one. All sorts of things like that all came together from being part of that process from start to finish. So I can't pinpoint one thing, but I can tell you that we were a different group of engineers than when we started. The other thing I'll mention, just also in the spirit of cooperation, I think in 2001, we had that, there were like 40 cells in that battery pack that was 5 pounds, and we were popping speed controllers like it was no one's business, like they were popcorn. Like every flight, they would catch on fire and pop, you'd hear it in the air, and it was a nightmare. We had reserves, but it was extra wind and, they saw some extra load and we popped one. So we were at the competition, we don't have another one. We just start asking around and everybody was like pulling out. At that point, there were very few motors to choose from, maybe just a couple. So we all used the same speed controllers. And so everybody, I remember Mississippi State, I don't know who they were, but I'll always remember Mississippi State gave me a speed controller for we could go and get a scoring run in. And that level of cooperation and, it's that, kind of AIAA collaboration that kind of carries forward, among colleagues and professionals. You see it at the competition, and that's also a lesson.
Camden?
Yeah, so a little bit of a different perspective. I think this is more from like a team point of view, but one of the things that Riddle DBF does, I think, particularly well is we kind of design by doing in a way where some of the teams I've talked to with this competition, and the beauty is you can approach it in so many different ways, but we tend to prototype design really fast and don't get too attached to certain designs, which I think is really important to learn as an engineer and in a professional space from the little professional experience I have, is to not get too caught up with a specific design and just kind of try and focus on the end goal, which is why I love showing the video where we're just prototyping and prototyping. And the other thing that is really important for us as well is knowledge transfer is absolutely huge for us. We've learned, 12 years of lessons and things of that nature through just us competing in the competition. That's super important to retain in the club so that those mistakes aren't made over and over again. So much to the point that we actually have a wall of failures like Ferrari does in our lab, where every major crash or incident that's happened or some design failure, we have it posted up on the wall, so we try not to repeat it over again. We do sometimes, but we just try to do our best in that regard. So.
All right, I'll do a really quick speed challenge here. First of all, Dave and Matt, we have a very targeted one for you. What was your favorite airplane nickname that OC gave out in the old days?
Oh.
You can come back to it.
I'm sorry, my brain cells are gone from that early. Matt, do you have any airplane nicknames?
I don't.
So if you go through, I will say all of the old scores and results are on the DBF website. If you go through that, you can see they used to give out superlatives to the teams when there weren't like a bajillion teams. Some of those are really fun to go through, and they also gave some of the OC members superlatives. So there's some really good memories in there if you dig through some of those really old PDFs. I'll go through this one quick with each of us since we're running low on time. What was your favorite DBF challenge from over the years? No description, just a real quick one.
It was the NASCAR pit stop where they, I think there's a couple of pictures here where students exploited hydrostatics in the same way that the NASCAR guys fill up with putting a high head pressure on and making sure there's a vent going in to replace the water. I love that one.
Matt?
Yeah, I think we had a year where it had to fold up into a tube and then come out and fly, and it was amazing to see these the airplanes that could fold up into such a small space. But.
I've got two. One year we had to fly PVC pipes on the wingtips. I think it was 2023. That was awesome. Ours almost failed in flight. That was really great. And then my freshman year, we had to drop these medical vaccine vial packages with the 25G sensors in every axis, and that was, I think, one of our craziest subsystems we've had to come up with. So.
Sweet.
I think one of my favorites from over the years, other than playing Gretzky, because it was incredible when one of these planes crashed and you see a really dramatic rolling of a hockey puck down the runway until someone fetched it. So I think some of those years when we have interesting payloads, some of the crash photos are really interesting. But the year before that in Wichita, we had a year that you had to build a large plane that could fit another smaller plane inside. And that smaller plane had to carry Gatorade. We lovingly called our Gator Tot and Big Bertha. And so that was really interesting to see the way that teams fit a smaller aircraft into a larger aircraft, kind of like a Super Guppy type thing. And so I think that was a really interesting design mechanism year. So one of them, I know we have a handful of students here, was Taylor, what were the struggles of establishing a DBF team at a new university? Really quick, it's kind of expensive if you don't have university funding yet. We paid out of pocket. Our first year, we did some crowdfunding, but it was mostly out of our pocket again the second year. And so if you can get backing from your engineering departments, from your undergraduate research groups, even from professors or just from some of the foundations that your universities have, your plane the first year is not going to be super elegant because you're probably not going to have the equipment yet. But start small, get to competition the first time, show your university that you're worth making the effort into and worth making the investment into, and then we slowly build up a budget. So now the Embry-Riddle team now doesn't have to scrounge for pennies under the couch, and that's a nice feeling knowing we left them in a good place. Let's see. So this one, I'll do the last one here. How have the design tools and processes used by the DBF teams changed over time? So Matt, I'm sure you might be working with stuff a little bit differently than Camden is. What were your base tools and processes?
Yeah, so that's great. It's interesting to see now, particularly when you look through the reports, and a lot of people are using, MATLAB and other things like that. We did a lot in Excel. Which is kind of embarrassing. I went back and I've gone back and read the reports that we submitted, and they were lousy compared to what's coming, what the teams are submitting today, which is really spectacular. So now, if you look at a report, you see all sorts of finite element analysis. We did wind tunnel testing, but a lot of it you could see was, we were even plotting some things by hand. It was weird. So a lot of changes.
So Camden, what kind of stuff do you guys work with?
Maybe not much has changed, not as much has changed as you thought. To be honest, my big propulsion sheet is in Excel. because I love Excel, but MATLAB, Excel, FEA, wind tunnel testing. Sometimes we get access to some interesting simulation software, but typically we're rocking it with the old school design textbooks, Roscom, Goodmanson from one of our college professors, and just going through that design process and iterating on it. So,
I think the greatest accomplishment I had on Design Build Fly at Embry-Riddle is I got us access to a laser cutter. We didn't have one. We were cutting ribs and frames by hand, and we got a laser cutter, and it changed the game. It was really a huge change in technology for us, and so I think that was absolutely incredible that the university was willing to spend $40,000 on a team that had gone to competition twice. And was not placing well yet, and that really turned around. Our tolerances in manufacturing went through the roof when that happened. And so the investment from Embry-Riddle there was incredible, and that made a huge difference for us. So I see my timer is counting up now instead of down. So I want to thank Dave, Matt, and Camden for joining me today and sharing some of the magic of DBF. And I have one final thought. I'm a big baby now and I cry a lot, so I apologize in advance for any tears. Design Build Fly is, oh, here it is, and always has been a labor of love. Having graded a lot of design reports and broken too many hearts at the ground mission, sometimes we do give you tough love. Remember that there are humans on the other edge that are judging your flights and judging your reports. Be gentle with us as well. We're going through it as much as you are at the fly-off. Whether you participate as a student, a report judge, or a fly-off volunteer, you have poured your heart into this competition. If you've been building this legacy at any point over the past 30 years, thank you for shaping multiple generations of aerospace engineers. And for those of you with a little bit of avgas left in the tank, help us continue this legacy for the next 30 years. So thank you for joining us today, and thank you for being a part of the Design Build Fly family. Thanks.